What if you could write code once and reuse it in dozens of classes? What if a single method call can make a dog bark, a cat meow, and a bird fly at the same time, and yet they are in the same list? That magic is possible because of inheritance and polymorphism, one of the most powerful concepts of object oriented programming. Hi there, I am Achala Ramakrishna here. Welcome to my YouTube channel Build Code with RK. In this video, we're going to get into the details of inheritance, interfaces, and polymorphism. Yes, if you want a cleaner code, a smarter code, and a professional code, please stick around. This can be a small, longer video, but I will be more hands on in this particular video so that we can learn the best. So, we let's get into understanding what exactly is inheritance. In the last video, we discussed about encapsulation, the different kinds of access modifiers, how to go about, coding with classes, etc. In this particular video, we are getting into the world of inheritance. So, what do you think of inheritance? What comes into your mind when it comes to inheritance? Yes. So, we inherit some properties from our parents. Sometimes you might have seen that, that one of the child exactly or more or less looks like, the parent, one of the parent. And another thing which I have observed is maybe this particular child looks like one parent, but or she has the mannerism of the another parent. I've seen that in many children. At the same time, that particular child has got his or her own, traits, her own skills, her own, properties, etc. So inheritance is all about inheriting from our, super or base classes, etc. Okay. So how can we associate that with the coding in object oriented programming? Now imagine I'm going to use visual paradigm. This is free, an online UML editor. And imagine that you have a class called cat, or let's say you have a class called car with, and then you have a method called how do you start a car and how do you stop a car. The same way you have other methods like you have, let's say, bike, and you exactly have the same method. Similarly, you can actually have another thing called, let's say, a ship or an aeroplane, and then you have a method called start and stop as the methods. Now, do you see anything common among them? So, do you see? I see that all these classes have the same methods. Now, most of the time, what we do is we are good at copy pasting, right? So, we'll go to the car class, copy the method of start and stop, and put that in the bike, and then maybe make some changes, small changes if needed. Similarly, you copy the bike class start and stop method and put that in the aeroplane method. Now imagine that it exactly is the same code which is being duplicated among the car classes, right? Or the bike class or an aeroplane class. Now this is where inheritance is born. To be very honest, inheritance solves many problems. One of the problem is code reusability. It lets you write a very structured and organized code and which is maintainable and extensible. That's the only thing which I love about inheritance. So what we can actually do is we can come up with a class called vehicle, correct? And put this method called start and stop there. Got it? And then what we can do is we can happily remove these methods. I'm deleting the start and stop methods from everywhere. Yet car can have its own properties, like, let's say I open trunk and all that. Now, please understand, this is just for reference. What exactly I meant by is, okay, so how is inheritance represented? So this is the notation of inheritance. See, slowly we went from pretty unstructured style of coding to a very organized code. Now, in this case, what have we done? We still have the start method and the stop method, and instead of duplicating across the car class, the bike class, or the airplane class, we have lifted it up into the base class or the super class. Now, vehicle class has got the start and the stop method. Now we can actually have dozens of classes which extend from vehicle, and we don't have to write something like, the start and the stop. Imagine you have an attribute called brand, okay, which is common among, all the kind of vehicles like car or a bike or an airplane and all. So the benefit of inheritance is code reusability. That's what I can actually say. Okay. Now let's get into the code. Now what I will try to do is I'll try to pick up a similar example. Like imagine you have a person class. So let's say that you have a student class, and then you have an employee class, and let's say you have a professor class. I'm using these examples for explanation purpose only, correct? And it is my perspective, and the interpretations can go different. Okay, so what I really meant by is I'm using these examples to explain the concept of inheritance. Okay, now what is common between student and employee and professor and all? Okay, so one of the thing which is common is the first name. Another thing which is actually common between the classes is the last name, or something like date of birth, etc. Now I can nicely rename this class to the person class. Got it? And then plug inheritance to the whole thing. Now you can actually see that the person, sorry, you can actually nicely see the person class extends from this. But the best part of the story is, now professor is actually working for that particular college, right? So professor is an employee of that particular college. So professor is extending from employee, employee is extending from that particular class called person. Now this is known as multi-level inheritance, where the degree of inheritance is 2. Now the actually, according to effective Java, it actually recommends to minimum go for 2 to 3 levels of inheritance. Because if you dig deep, right, then you might get into, more complicated design. That's exactly what they meant by try to have 2 to 3 levels of inheritance, and try to incorporate it. But do justice to the requirements. That's what exactly it is saying. Now let us go for the implementation. Now I'm actually going to go to Eclipse. I have a ready-made project called Inheritance App Ready. Now let me come up with the class. Now, as you know, we have been using Eclipse. So let me come up with the person class. Okay. Now, now, and then you have the class called student. Now, instead of adding, the details like first name, last name, etc., in student class, because these properties even an employee has or a professor has and all kind of things, if we put it inside the all the classes, then it leads to code duplication and all kind of thing. The codes become mess. So the right place to put all the common elements is the person class. So let me say that, I have something like private string first name and private string last name. So, and in the student class, okay, let us keep student related attributes like private int roll number, private string in which grade he's or she's studying, and the college. That's it. So what we will do is we will come up with we'll come up with the getters and setters. Okay, and let us also come up with the constructor. And let us add a constructor which takes, both the arguments, the first name and last name. It looks nice. Now, at the face of it, we can create an instance of the person class. Now, that is a design choice whether you really want the person class to be instantiated or not. If you are fine with creating a person class, if actually the person exists, you can leave it. But in reality, why did you created the person class so that you can get the benefit of inheritance? So in reality, there is no such thing called person exists. You have created. Now, if you so as this video progresses, I will get into the discussion of abstract classes, okay, and how can you restrict a class to be instantiated, all the kind of thing. So let's start small rather than getting into all the details, and let us deal with all the concept, step by step. Please do understand that this is going to be a detailed video, and I'm going to finish all the concept of inheritance and polymorphism in this video only. You can take a pause and keep listening it. And this is a hands-on video, so please open your Eclipse and laptop and start coding with me and then have fun. Now this is a person class. Now what we can actually do is we can say, how do you connect or how do you implement inheritance? Now in Java, you say extends and then person. So when you do this, then the student class extends from the person class. Now what we can actually do is I can put the setters and getters, correct? And we can actually come up with the constructor also. Ah, okay. Now, this particular constructor, you can actually see this is a very nice, constructor. Now, you know that student extends from the person class, okay? But the person who is instantiating the student class doesn't know. So assume that, I'll go for instantiating the student class. Now, for the sake of easiness, right? Who is going to display too many things, right? I'm going to add a toString method too. That's it. No, I'm going to add the methods of the base class too. So if I say toString and then inherited methods, get first name and get last name, and then you can actually see that it displays the whole thing. Now let us go for instantiating it. Now let us say student is equal to new student. The first argument is I need to check at the constructor. Now the first argument is the first name, last name, and then the whole thing. So here we can actually say Ashok Kumar, and then you have roll number as 1, the grade as let's say 8, and let's say he's studying in Greenwood School. Okay. String int. I think here I have to put, let's say, grade 8. Yeah, now that's good. See, you will get errors. You need to have patience and then you need to actually fix it. There is no need to worry about it. Now, when I do system.out.println, yeah, So where I can actually double click here in the app.java, right click new and run as Java application. See, you get the output, correct? So basically what have we done? We implemented the student class, which is actually extending from the person class. The whole world doesn't know that. By looking at this app.java, you will think that student class itself handles everything. Okay. Now, what we can actually do is we can go for adding another class called employee. If you want to match the Eclipse IDE, right here in the super class section, you can actually say person. Yes. Now you can say finish. Now you can see that the employee class extends from the person class. Now, what are the kind of properties you will have in an employee class? Now, let's say that you'll have employee number. Now, you'll have something like designation. You have something like salary, etc. I don't want to complicate it. I'm just leaving it with three attributes right now, but you can have a whole lot of it. Now, let us implement getters and setters. Okay, and let us also implement the constructor. Fantastic. Now let us implement the two string methods and let us add that get first name and get last name into the two string. Fantastic. Now this is a classic example of inheritance. Now if you see employee class is not bothered about first name and last name because it is internally dependent on. Now just one thing which I wanted to explain is this particular code called super first name, last name, and all. Now, what happens is, now let me instantiate it and then explain it. Now, whenever you say employee is equal to new employee, and then the first name is, let's say, Ramesh, and then let's say Sharma. I'm just using some names, and then you can say two, and then let's say you have the software engineer, and the salary is a handsome salary. Let's say he's getting 50,000 rupees per month. Okay. Now when I do system dot out dot println and then say employee. Now when we run this particular program, here is the student object getting instantiated. Here it is the employee object is also getting instantiated. By looking at this app.java, they will think that somebody has written a student class which contains the first name, last name, and the other properties, and employee class which contains the first name. So the people who are using employee class thinking that employee class contains first name and last name. People are right who are using student class thinks that student class contains the first and last name. But technically, what did we do? We created a base class called person and then and took out all the common properties and put it on there actually. Right? Now let me explain to you how the whole thing get executed. You know, now you have the student class. Now this particular student class has got technically around 5 parameters. Now you can hold on the control key, and when you click on the student, right, it actually directly takes you to the constructor. Now, now you see the student constructor has got first name, last name, and all. But the question is, do you think the do you think first name, last name belong to the student class? No. So you need to do constructor chaining. That means one constructor calling another constructor. That means a student is like a derived class, person is like a base class. So student constructor is need to call the person constructor, right? And how it can call? By using the super keyword. Please understand that if you can't write this particular super line anywhere else, if you write like this, the code is going to give a compilation error. It is a Java requirement that the super keyword which calls the base class constructor should be on the first line. Same way in employee.java also, the super keyword which calls the base class constructor, that is person constructor, in the first name. Okay. Now this is the implementation of inheritance. Now, what kind of inheritance it is? It is a single inheritance, because you can actually see that the employee class extend from the person class. Now, actually, we can have multi-level inheritance. That means we can create another class called professor. Correct? Got it? Now, the professor class can extend from employee. Please understand, I am building this particular YouTube video so that you get the exact hands-on way of coding inheritance. Okay. And let's say that the professor class has got something called the subjects he's going to teach. Let us assume that he's teaching one subject. Otherwise, I have to create a list of subjects and all kinds. Now, let us create getters and setters. Correct. And we need to also define a constructor for the professor class. We need to be very particular about constructor chaining. Now, when you see it here, the professor class has got lots of parameters. You see, now the professor class has got first name, last name, which belongs to the person class. It contains employee name, designation, salary, which is coming from its immediate base class called employee. And finally, the subject is. Now, what are we doing in the line? This super of first name, last name, employee name, designation is calling employees constructor, and this line number 14 is calling the person constructor. So that's how the constructor chaining is happening. Now, wow, we made a multi-level inheritance. Now when you do professor is equal to new of professor of, let me copy this whole thing and change the values accordingly. I can actually put, let's say, physics, and then enter. Now we can actually say system.out.println, and then you can say professor. This is the beauty of inheritance. What I meant by is, the people who are actually using the professor class don't know that it is internally being inherited by employee. Employee again is inherited from person. So how structuredly we are writing the code. And believe me, if you are good at writing inheritances and interfaces, your code will be so organized, there won't be any duplication and all. And the life of your code, goes very long, as long as the life of the product. Now let me run the program. I'm assuming I have added the toString method. Okay. Now I think I have not added the toString method. Easily I can make out. Now when you say source, you should not panic. Okay, if you haven't implemented it, then you can as well correct it, right? I'm selecting the inheritance method. Now when I run the program, you can actually see. Here it is, the professor class and all coming. Now look what exactly we have discussed. We discussed that inheritance is a kind of relationship. The essence of inheritance is code reusability, correct? And I've drawn some UML diagram explaining the notations of. Now, what exactly is the benefit you get from inheritance is the common properties and the common methods which are across classes can be lifted to one level and that can be reused. And at the same time, you can add new implementation towards the subclasses or derived classes. In C++, we used to call derived classes. In Java, we call that as a subclass. What exactly is a super keyword? Super keyword allows you to call or access the base class function. What exactly is constructor chaining? As you have seen in your code, whenever you're creating an object, the constructor gets called, correct? And the constructor calls using the help of super, it calls the base class constructor. In this case, it is calling employees constructor, and employees super code is calling person constructor. So this essence of calling, the base class constructor is called as constructor chaining. What is method overriding? We'll get into this particular concept pretty soon. Now, how many different types of inheritance are there? You have single inheritance. So if you have only student class extending from person or employee class extending from person, the level of inheritance is single, one parent, one child. What is multi-level inheritance? Multi-level inheritance is the chain of inheritance. So you have professor class extending from employee, employee class extending from person. This particular, the whole thing is known as multi-level inheritance. Now, in languages like C++, you have multiple inheritance where one particular class can extend from two classes. But Java doesn't support multiple inheritance, because we get into this diamond problem and all kind of. And there is a way to, get away from multiple inheritance. And since Java supports interfaces, we can easily achieve that feature. It's done very artistically. So once you learn interfaces, you'll understand this concept better. Yes. So we have done multi-level inheritance, etc. So so technically we are end of the concept called inheritance. Now the second concept in this particular video, I'm going to take it as polymorphism. Believe me, polymorphism and inheritance is the reason why most of the code in production exists. Most of the production code is stable. So what exactly is polymorphism? Poly means many and morph meaning shape. So if you want to go by the definition of polymorphism, polymorphism is the ability to hide different implementations behind a single interface. I want to repeat this. Polymorphism is the ability to hide different implementations behind a single interface. Now, there are two types of polymorphism. One is compile time polymorphism, the other one is runtime polymorphism. You've learned method overloading from me, where one particular method, where more than one methods can have the same name. Look at this particular slide. The class is calculator and it has got three methods. The first method takes two integer arguments and returns an integer. The second method takes two double values and return a double value. The third method takes three different parameters and return a integer again. Now, some method overloading is possible as long. So technically, what exactly it is? In simple language, it is the ability to give more than one function the same name. Right now, there are three functions, but we have given the same name. So add is the same name for three functions. How is it possible? When is it possible? You can have more than one function with the same name as long as the number of arguments are different. If you see these three functions, the number of arguments are different, right? Or the type of arguments are different. But you can't actually differentiate based on return type. That means if two functions have the same parameters but they only differ by return types, compiler cries. Got it? So this is the concept of overloading, static binding. The next concept is what you call as runtime polymorphism. This is one of my favorite topic actually. Now, before getting into the details, I would like to get into the code and slowly explain this concept. I wanted to explain inheritance and polymorphism together because those who are following my video, right, and can learn it much better. I don't want them to be distracted, to search for another video actually. Okay, so before jumping on to giving a meaningful example of polymorphism, I just wanted to explain how the syntax works. Okay, now now let's do one thing. Okay, now let's create a class called base, and let that class has a method called public void show, and let it have a out method called system.out.println, and then say base show. Okay, now I'm getting into the concept of polymorphism, but I just wanted to explain the Java syntax first, how exactly it works and all, and then I will give a realistic example, and then you can actually understand the concept better. This is exactly what I want. Now let us create one more class called derive. Now this class extends from the base class. Okay, and you can actually have something like public void show, and then you can say system.out.println, and then you can say derive show. So what exactly is happening is, now let's come back over here. Now I will say level 1 just for understanding purpose. So when you say base is equal to new base, and then call base.show. Now please understand, at compile time, the signature show function belongs to the base function. So when you look at this code at compile time, you can easily run the program, right? And then you can get an output called base show. This is just level 1. Okay. Now let's get into level 2. For simplicity purpose, not to confuse you guys, I'll just comment the level 1 code so that we can actually get into level 2. Now here, let us create a derived object and instantiate it, and then call derived.show. Now what is common between base and derived class? Now base class has got a show method which doesn't take any parameters and doesn't return anything. Now this void show is a method signature. The same signature exists here. The same method signature. See, even if I cut copy paste, it is exactly the same thing. So since it is derived object, right? The signature show, the show method belongs to the derived show. So right now when we run the program, even though it is a world of inheritance, if the same method exists in the base class and the derived class, if the same method exists in the base class and the derived class, then what happens? The derived class functionality gets called. You can actually see this. Now let us get into the world of level 3. Now in the level 3, let's see how Java works. You can actually create a base reference, okay, and you can instantiate the derived object. Now this possibility is there in case of inheritance in Java. Like if derived class extend from base class, then you can create a derived object and store in the base reference. Now when we call base.show, now please see here, this is the magic. Okay, at compile time, the show function still belongs to the base class. At compile time, the show function still belongs to the base class. Correct. But when you run the program, since the base reference contains a derived object, okay, so overriding takes place and it skips the base class functionality and it calls the corresponding derived class functionality. Now what happens? The output is derived show. Now see here, write Java application and then you're getting the output. So even though you're using the reference of the base class, whenever you instantiate a derived object and store it in the base reference, then method overriding takes place. That means you skip the base class functionality and you call the corresponding derived class functionality, even though you are using the base reference. This is magic actually. Now, I just wanted to tell you one more. Let's say that you create a new class called new derived. And then you say extends base. Got it? And you exactly have the same method signature. Now you say new derived. Got it? Now, when I go back to app.java, now I'll actually use the same reference and then you say new derived. And then call the same method. Okay. Now look at the beauty of the code. At compile time, base show belongs to the base class. But at runtime, since line number 23, the base reference contains the derived object, the derived show gets called. And line number 26, since the base contains new derived object, the new derived show gets called. That means we can toggle between one derived class object to another derived object via the base reference. That's kind of foundation to polymorphism. It's like the ability to hide different implementations behind a single interface. Now, before getting into a more realistic example, okay, what I'm trying to do is can we do this? Like derived is equal to new of base functional. Now this is not possible. Okay, you can do casting, you can corrupt your code, plus please don't do it. So please do not instantiate a derived object and store a base reference. In Java, it actually doesn't allow. Now, now let me explain the keyword abstract. Now, if abstract, what happens when you make the keyword abstract? Now, the moment, see, right now it is a normal class, right? Right now it is a normal class. So in the app.java, you can happily say base is equal to new base. It works. And then if I say base dot show, correct? And then it will say base show. This is, nobody can stop it, right? Looks like I have got, okay, I'll say base one and I'll say base one. Now looks like, you see, if I can easily run the program and then you set base show. Okay, what if you have come up with a base class for inheritance purpose and base class doesn't exist? What if you want to restrict people instantiating the base class? So if you make the keyword abstract, right? If you make the keyword abstract, what is abstract? Abstract is the keyword abstract. It restricts the class from instantiating. And the benefit is for derived classes only. So you are purely coming up with the class called base for inheritance purpose. You're actually not instantiating. So in my previous example, right? In my previous example, I can happily make the person class abstract. What happens if you have a person class abstract? So nobody can directly create a person object. That's actually the game actually. Now all of you please understand here, an abstract class, sometimes I like writing the concept in the close. An abstract class can have properties, that is first name and last name, and can have behavior or methods, correct? And that can be reused across the derived classes. You can, what happens if you make the class abstract? you can restrict the class from instantiate. Okay, now there is one more concept. If I'm not going too fast, which I wanted to tell you. Now in the interface app, right? In the interface app, you got an error is because you made the class as what? Abstract. So what exactly is the benefit of making the class abstract? You restrict the class being instantiated. Now next, what is the benefit? You are leaving the you are you created the class so that you can put the common properties in one place, and you can put that as part of the inheritance. Got it? Okay. Now you can actually make sorry you can actually make this method also abstract. Now what happens when you make the method abstract? Correct. Now you don't, I'm just commenting this piece. See, let's be honest. Let's be honest. In the app.java, when I say base is equal to new derived, base.show is calling derived show method. And when you instantiate a new derived object, base.show is calling new derived show method. Nowhere we are calling the base show method. If you are not calling the base show method, why do you have it, right? So you can leave it as abstract. So what happens when you make a method abstract? You're leaving it for polymorphism perspective. That means you don't have any implementation on its own, and you expect the derived classes to implement it. Got it? Now let me give you a realistic example. I think I have been playing around for a long time by just explaining the syntax of how overriding takes place. Now let me explain to you a realistic example. Okay. Now let's talk about printing. A very simple example. So let us actually come up with a class called printer. Okay, and then let us say void public void print method. Okay. Now I wanted to explain the concept of interfaces. So we discussed about compile time polymorphism, runtime polymorphism, etc. And then we discussed about abstract classes also. Now the next thing we'll get into is the interfaces. Now all of you, okay, now what exactly is an interface is? Interface is one of the most important concept in object-oriented programming. Name it a language actually. Now interface is a contract. Interface is a set of rules. Interface is an implementation. Correct? Interface is not an implementation. The classes which implement the interface will provide the implementation. See, I've been traveling in Java for a couple of decades actually. Now, this is my definition, which I have been carrying it on my own actually from quite such a long time. And this is what basically I understand. Maybe the bookish meaning might be different actually, or someone else can interpret it in a different way. So, what exactly is an interface? An interface is a contract. Now, I just wanted to tell you is if an abstract class has all abstract methods, it is as good as an interface. Okay, now I repeat, abstract class can have its own state and behavior, its own attributes and methods. But if you define an abstract class with all abstract methods, you can might as well add it as an interface. Now let me define an interface called printer and then do it, right? Now I can easily rename this interface keyword to abstract class and then leave it as public abstract void print. It actually works. That's exactly according to me an interface is. Okay. Now let us go for its implementations. Now, if you see the way printing as a technology evolved, right? We initially had something like dot matrix print. So let me actually say dot matrix printer, the printer which makes sound noise, kind of thing. Then you say implements printer. Okay. Now, whenever a class implements an interface, it is mandatory that it has to implement all the methods of that interface. So see, there is an error, and then you see add unimplemented method. So you get it here. Now I'm actually typing something like system dot out dot println, and then you say printing via dot matrix printer. Okay. Now after dot matrix printer, you have inkjet printers which came into the market. So you have inkjet printer, correct? Which implements the printer interface. Okay. Remember one thing. In case of in case of classes, it is extends keyword. In case of interface, it is implements keyword. Those are two different keywords we should be there. Now here I'll say system.out.println printing via dot matrix. Sorry, via inkjet printer. See, I'm a human being, right? I'm bound to make small mistakes. Please forgive me if in this whole video, if I made one statement wrong, you can put that in the chat. The whole, you can give a comment. The whole people who are following my video will understand. But I'm doing this video with honesty so that the younger generation, the new engineers can get benefited. I know that my code works. So if you understand my code, I'm more forward. If I'm wrong with 1 or 2%, please forgive me. And I'm trying to do my best. But if you find my mistake, I learn from you. You are my guru actually, and I really respect. Okay. And I'm the first student of whenever I take a class. So I really love teaching. That's the reason I'm teaching actually. So I don't care about how great my knowledge is, but I care about sharing my knowledge. Yeah. So you have an inkjet printer implementing the printer interface. Now what we will do is we will come up with a word class, okay, and implement it. Now let me actually give you a design level analogy about what I'm trying to say. Now you got an interface called printer, and the printer class has a method called print. Got it? Now there is a class called dot matrix printer, and the matrix printer, I have a method called print. Correct? So the dot matrix printer see, this is the realization relationship. Similarly, we have a class called inkjet printer. So inkjet printer also implements the printer interface. Got it? After some time, no, the laser printers came in the market, and you have implement and laser printer also prints. So you can actually say that this is how it is. So in UML notations, right? This symbol, the diamond symbol, the equilateral triangle symbol is inheritance, and the equilateral triangle with dot line, They are basically implement relationship. In fact, in UML class diagram, you have other relationship like dependency, which is a task-based relationship. You have a aggregation relationship, which is one to many has a relationship. You have a composition relationship, which is a specialized aggregation, right? So I would like you guys, if you want to be good at designing or architecting it, you should have a grip on these kind of UML diagrams. See, your understanding improves. Now, let me come back to a class called Word. This is my MS Word app actually. And let's say it has a method called doPrint. Okay, now this guy, Word class, is depending on this particular guy. This is exactly what I was trying to say. Now, please understand, MS Word has been the existing from past 45 years, right? Now, in the first decade, maybe dot matrix printers were there. Now, MS Word guys, the people who have written the Word application would have said that we should actually write a standard code where, irrespective of newer implementations, our code should be same. There is a one of the solid principle is open close principle. It says that when the server adds extensions, that is you add from dot matrix to inkjet to later, the client code is relatively close for modification. So in the sense, the code inside do print is relatively close for modification, irrespective of newer implementation classes we actually add. I'm going to take a separate video on solid principles, is because those who are trying to prepare for design interviews, like when you are applying for a job or for a senior software engineer or a tech lead or an architect, then they will ask questions on design patterns, on solid principles and all. So I have a separate playlist applying for design patterns. You can actually learn from there. Now what we I am trying to do is, okay, now this is where I am in the do print. So if you see here, I have the printer interface, correct, with the print signature. I have the dot matrix printer with the print implementation for dot matrix printer, for inkjet printer. Now let me implement the laser printer. Now when I use the printer keyword in the interfaces, enter, 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 and then you see it adds or it implements. Now you can actually say system dot out dot println, and then you can say printing via laser printer. In fact, I have tons and tons of examples on this. I choose this because it is easier to code. Now let me implement the word.java. Here I will say public void do print, correct, which actually uses printer as the parameter. If you have a dependency relationship between a class and an interface, you should exactly pass it as parameter to one of the methods. And you can actually say something like printer.print. Now, technically, if you are following open close principle, right, this code I can actually say. So I would rather not be so cold. I can say this code is closed for modification if newer printers arrive. Simple, simple. That's exactly what it is. This is exactly what you call as the open close design principle. Now, let me create a new class called interface main. Let me finish the whole code and then I will summarize the whole story and I'll tell you the real benefits of interfaces. Now let me come up with a menu generated flow. Simple. So we'll say int choice is equal to 0 and then say printer is equal to null. Correct? And then we'll say word is equal to new word. I'm just adding an object. Now we can say while true, and then if we say, let's say system dot out dot println, and you say print one dot print via dot matrix. Similarly, let me copy. So I'll say print like this. Now print via inkjet printer. See, in MS, in you can go to add printers, right? And change your default printer from dot matrix to inkjet to laser, right? It's a realistic thing, you know. I'm not joking actually. Now you can actually say something like 4 and come up with exit. Here I can actually say choice is equal to scanner dot next int. So let me create a scanner because I'm just trying to take input from the keyboard. So new scanner of system.in. The scanner is in the java.util package. So you can actually import like this. Simple. Got it? Now I can actually add a switch statement and add choice over here. And I can actually say case 1. And then you say printer is equal to new of inkjet printer. Sorry, dot matrix printer. Control shift will, you can identify that. Okay. And then say break. Now I can actually copy this for case 1, case 2, case 3, etc. So for case 2, right, you can actually say something like inkjet printer. For case 3, you can make something like laser printer. For case 4, I can actually say system.exit. Something like that. Now after the switch case is over, I'll say printer.print. Now please do, okay. Okay, I think I made a mistake. And I am the first person to admit the mistake. So we can actually say here something to look word dot to print, and we can actually pass the dot matrix printer. So okay, now same way I'll paste this here and I paste this here. And here I'll say something like inkjet. Yeah, sorry, this is what exactly I want. Made a mistake, I apologize. Now what are you trying to do is you're calling the doPrint method of the word class and you're passing the dot matrix printer as an object at runtime. Now this is a true runtime polymorphism is because when I run the program, at that time a particular case gets executed. At that time that particular object gets created and then pasted and then sent to the thing. Now I think more or less I'm done. This is what I had planned actually. So when we run an Java application, right now, I'm lucky today, less errors. So, okay, so if you enter 1 as an output and 1, right, then it sees printing via dot matrix print. You see, now if you enter 2, it says printing via inkjet printer. Now, similarly, if you enter 3, it says printing via laser printer. You type 4, right? See, the program terminates. See, so the beauty of this particular code is, all of you, please understand, interface at the time of compilation, you will have, see, this particular code, is a true code of runtime polymorphism. At the time of compile time, printer.print, you can no way tell that it is going to call which method, whether it is called the inkjet printer or a dot matrix printer, etc. At runtime, you see this particular code. At runtime, depending on the choice what we enter, that case statement gets called, and that corresponding object at runtime gets instantiated and getting passed to the interface reference, and then overriding takes place, and accordingly either the dot matrix printers print method is called, or inkjet printers print method is called, or the laser printer print method called. Now interface is all about extensibility. It is for so sometimes people say what should be the best practice for design. So the best practice for design is step one, you should take care of the current scenario, all the permutation and combinations which you have. At the same time, you should leave a placeholder for future reference. What do you mean by that? Like in today's world, right? You have 3D printers evolving, right? Imagine the code is in production from past 5 years. And then suddenly, the new kind of printers came called 3D printer, right? And the 3D printer also implements this printer interface. A class name or interface name cannot start with words. That's what it means. So imagine that you have the printer interface, and then you can easily say system.out.println, and then you can say printing via 3D printer. Now, this is the implementation which I'm implementing after 5 years of the code. Now, believe me, this particular code is closed for modification. Correct? That's the benefit of real interfaces. Now, I can easily go to my interface main class. I can just copy paste this one and then say 4 and 5 here. I can actually say system.println and a choice. Last time I forgot this. And then I can actually say 3D printer. Now when and then come over here and then I copy this, and instead of laser printer we can easily add 3D printer. That's it. Now when we run the program, right, you run the program, okay, and then you enter the 4. Now the output is coming as printing via 3D printer. Now if you implement your projects using interfaces, your code will be extensible and code will be scalable. Now let me give you one more realistic example of interfaces. Now please understand one thing is India is pretty popular on UPI. I think the whole world has appreciated our digital UPI technology. Correct. So we have lots of apps called Phone Pay, Google Pay, and Paytm and all these kind of applications. So you can easily go to a vegetable vendor. In fact, all the vegetable vendors, street shops, the whole country is using UPI actually. Nobody, very less cash transactions happen. Most of the things are all digital transactions. This is New India, which I'm actually talking about. Now, what I'm trying to say that is when you use your phone pay app, you scan. You decide at runtime, whether you want to make the payment using HDFC Gateway or ICICI Bank or SBI Bank or Canara Bank and all, right? And the payment happens. According to me, there should be an interface called Payment Gateway, correct? And then payment, and that is what is been implemented in the phone pay app. And then you add implementations of HDFC, ICICI, SBA and all kind of things. The whole implementation is done via interfaces and runtime polymorphism. What I'm trying to tell you is in 2027 If a new bank comes, let's say Hello Bank, and the existing phone pay bank will add a newer implementation for a Hello Bank, the interface remains the same. Most of the code remains unchanged, and they can easily incorporate new banks as and when they come in. So most of the products in software have been in such a safe place just because of interfaces and polymorphism. Now we have come to the end of this particular video. I know it is a long video, but I had to do it in one shot. The reason is I trust my users. They will pause the video, they will say how I code, they will open Eclipse and they'll practice, and they will use this as a lecture. And believe me, if you tell these things, you'll get through jobs. Thank you everyone for attending this video on interfaces and inheritance, and hope you love it. Please subscribe to my YouTube channel, Build Code with RK, and I'll come up with newer videos. In the next video, I have plans for exception handling and then collection classes. This is a full stack Java series. Started from scratch, and sky is the limit. Thank you very much. Bye bye. Have a good day.